lesson 93, dot plots and looking at outliers. So again, this is another data visual representation that we've done from middle school that we're going to now revisit here in Algebra 1. So here's our criteria for success. So watch as I'm discussing and modeling that we represent each data point with a dot above the corresponding number on the number line. That we can calculate the appropriate measure of center. So just knowing mean, median versus mode, everything we talked about in the last lesson, and if possible, compare the two data sets using the center, the measure of center, or the spread. So some high-level information. We already know a dot plot is, again, just another way of representing the data where every single dot represents one data point. And so it's really helpful because we can see the frequency. We can see how many times a particular value came up in the frequency set. And an outlier is kind of what it sounds like. It's one that's outside. It lies outside the values of the data set. So it's either much greater or much less than everything else, and it stands out from all the other ones. So one thing about outliers is that it definitely moves the data. Like, let's say every single person, just looking here, this is salary. Most people have their salary concentrated around here. This one over here would be the outlier. If this one didn't exist, our average might be much lower, but because of this really high number, it's going to make the sum much higher, which pulls the average a little bit more towards this direction. So that's what outliers do. They can change our averages by making them slightly higher or lower depending on how far away they are. The other thing about data distributions is that they can create skewness. So what that means is, pretty much, we talk a lot about bell curves. Like, a lot of our data, it kind of gets in the middle. Like, when you put in all the natural data, we like to make a perfect natural bell curve where it's nice and symmetrical, kind of like this, where most of the data is in the middle. So that's perfectly symmetrical. It looks pretty balanced. However, sometimes it can be a little more balanced. Like, there's an outlier that pulls it to the left a little bit, or an outlier to the right that pulls it to the right. And so it's no longer perfectly symmetrical, and now it's skewed, it's pulled to one side or another. It's almost like it has a little tail now. And sometimes I used to draw this almost like a fish with a tail, so I can see the skewness. And if my tail is to the right, then I know I'm skewed right, and if my tail was to the left, then I was skewed left. And that's kind of how I used to tell the difference between them, just drawing the tail, make it a tail of a whale. So here I'm just going to very quickly model out a problem. Here's my dot plot. It shows the number of pets owned by students in the class. Which statement would not be true? So I need to actually look at all of these, and that's what makes this take a little longer. I need to actually check to see which of these would not happen. So that means I'm going to look at the median, the mean. I'm going to check for outliers, and that means I also have to do a box plot and find the IQR. All right, so let's start with median, because that might be the easiest one to start off with. And what I like to do for this one is to just start crossing out. And I'm going to cross out 4 here on this end and 4 here on this end. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So my median is going to be 3, so this is true. And so I have to cross that one out because I'm looking for the one that is not true. Okay, let's do inner quartile range. I'm going to erase this again. I'm going to have to here to here. I know my numbers go from 0 to 6, but I do need to find my median, which we already did, was 3. So it was one of these two numbers here. Okay, so let's put all the other numbers in order. So on the other side I had 0, 0, 1, 1, and I had 5 2s and one of the 3s. So I'm going to do the same thing, cross out till I get to the middle. And I know it's going to be a 2. That's the first part of my box. And I'll do the same thing on the other end. So here are my 3 3s. Well, I had one of these over here, then the 3 3s. My 3 4s, 5 5, and 6. And I start crossing out again. And it's going to be a 4. So here's my quartiles, my Q1, Q2, Q3, and Q4. So remember, the IQR is where I subtract 3 from 4. I'm sorry, 3 from 1. So I'm looking for this distance from here to here. And so I just need the numbers 2 and 4 and find their difference. And it is 2. So this is also true. So we keep on going. All right, let's go to mean. And I will say I use the calculator on this one just to spend time, because you don't need to see me just typing in a whole bunch of numbers. And when I added all of these up, I got 55. And my total number in the set was 20. So when you divide, you end up with 2.75. So boom, not true. So that one's the one that is definitely not true. It is false. And the last one was, is there an outlier? And there actually is. This 6 pulls is a much higher number than the other ones when we calculated it out. So it's slightly outside the norm of all the others. Okay, so there you have it. C is the one that is absolutely false. So let's jot this one down into our notes. All right, let's do a guided practice. Try this one on your own. Hit pause, read the problem, and try to figure out which statement about the data sets is correct. All right, let's do our reveal. The one that is actually correct would be D. Because that one does have a greater mean. Basketball players have a greater mean than the soccer players. So just visually we can see that, because we can see a higher concentration of their ages are older than over here. So I know that my data is just going to be higher in this regard. But let's figure out why the other ones are false. The first one says soccer players are skewed right. And I don't have that long tail at the end. This is actually almost, they're all kind of concentrated in there. So no. There's not really a skew. If anything, there's a lot more data being on this end happening here. The second one, the data for soccer players has less of a spread. Also not true. They both have the same spread from 6 to 12. So it's the same range. And the next one being, what is the median? So it's saying that they both have the exact same median. And I can tell that was going to be true because more of my that was going to be false, because more of my numbers are here on the right, whereas here they're a little bit more on the left. So if you actually went and started crossing out, so 1 2 3 4 5 6 7, 1 2 3 4 5 6 7, here my median is going to end up being 8.5. Whereas for basketball players, the median age 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 4 is much higher. It's going to be 10. So you can see that they don't have the same median. The basketball player's median is much higher. And like I said, if you went and actually added up all the numbers, you would see that the average mean for our basketball players would be higher than our soccer players. For the basketball players, our sum total would have been 178 divided by 18 gives us 9.8 repeated. And for the soccer players, it was 156 divided by 18, which gave us 8.6 repeated. So that one is the one that is correct. All right, so that's it for today's lesson, Math Marbles. Again, you're just calculating, make sure you're attending to precision and using your criteria for success. So every point means a data point. Make sure you're calculating the right average that's being asked, and then just comparing the data sets. That's it for today. I'll see you in the next one. Be well.